Now I would like to introduce our speaker for today, Eric Ndayishimiye. Sorry, Eric, I think I've got your surname wrong again. You'll have to bring it up yourself. But Eric is a great friend of my old friend Winnie, and she's now working for the Gorilla Fund in Rwanda, the Dian Fossey Gorilla Fund. And Eric has been supervised by Winnie. So I know that if I meet Eric, I'll also be a great friend with him, because Winnie is a super supervisor and researcher. And I'd just like to say that that Eric is now almost on his way to becoming a doctor. He's doing a doctorate with Nottingham Trent University in the UK at the moment. And he's looking at the physiological response to social stresses with adult male mountain gorillas, in adult male mountain gorillas. And I'd just like to talk about the obvious skills that Eric must have in doing this kind of research. He clearly has a lot of fitness and stamina because he's in the forest following gorillas and monitoring them and collecting data. He has a lot of passion and dedication to do this work. He has to be patient and have a lot of patience with his research, because the PhD is a very long and demanding journey. Eric, just to go a little bit backwards, Eric did his BSc in science, and as Winnie said to me, he was already shining as an outstanding student at that time. So well done, Eric. He then went to go and work at the Dian Fossey Fund from 2015 to 2023 on their gorilla program. And at first he was a research assistant and then became the research officer. He did his MSc at the University of Chester in the UK, and his thesis was titled Human and Golden Monkey Conflict Around the Volcanoes National Park. And it's this research that Eric's going to share with us today. And Moret is also going to share with you a link to the paper that he published, which emanated from this MSc research. Moret, when you can, just share that link for anybody that would be interested to go deeper into the subject. But now, Eric, I would like to invite you to the stage, and I think we're all going to enjoy your super presentation. So thank you very much.
Thank you, Kristen, for a very, very nice introduction. As Kristen said, I'm today, and I'm very happy for this. And my talk will focus on two things, basically. One, I'll tell you the basics or principles of human-wildlife conflict definition and mitigation measures. And then the next focus will be me sharing with you the findings of my project on human-wildlife conflict in golden monkeys around Volcanoes National Park here in Rwanda. So a bit about me, as Kristen has said, my name is Eric Ndayishimiye. I'm a PhD student at Nottingham Trent University. I'm a research affiliate for the Dian Fossey Gorilla Fund. The Fossey Fund is an organization that is dedicated to the conservation of the mountain gorillas here in Rwanda and in DRC. So I have a master's in biological sciences that I got from University of Chester in the UK, and also a bachelor's of science from University of Rwanda. I have experience working with wildlife. I started working with gorillas back in 2015 when I was a research assistant for the Fossey Fund. I worked with gorillas, going in the field, following them, collecting them. This is me. This photo is my photo in the field with gorillas. So 8 years working with gorillas. I also had the experience working with golden monkeys, which is the second. Actually, in the Volcanoes National Park, there are only two species of primates, so the gorillas and the monkeys. So the golden monkey is the second species that is found in the Volcanoes National Park. So I had the privilege to work on both of those primates. To get started, according to Madden, human-wildlife conflicts occur when the needs of and behaviors of wildlife impact negatively on the goals of humans, or when the goals of humans negatively impact the needs of wildlife. So it goes on both ends. humans can have, a negative impact on the needs of wildlife, the same as wildlife behavior and needs can also have negative impact on the goals of humans, and this creates a tension between human and wildlife. Examples of wildlife conflict can be crop damage. Animals sometimes get out of their protected areas and damage or feed on crops. They can also kill or injure domestic animals. Lions sometimes get out in some protected areas and feed on livestock. So this can create conflict. This can be an example of the conflict. Also, some wildlife threaten or kill people. You have cases of elephants, for example, because they are huge in size. They sometimes come out of protected areas and kill and injure human beings. On the other hand, humans also retaliate. They get angry and they can kill wildlife as a revenge to the threat they are having from wildlife. So the mitigation measures for human-wildlife conflicts are grouped into two categories, according to some scientists. Some are direct interventions that aim to reduce the severity or the frequency of encounters between wildlife and people and their property. So direct measures, they aim to reduce or minimize the interaction between human and wildlife. And the examples of those measures are, crop guarding. You have someone who's looking after crops for a period of time to minimize animals jumping into fields. Physical barriers. In some protected areas, they have barriers, fences around protected areas. These are measures to minimize the frequency of wildlife jumping into fields. Experimental reference. I come back on this in a short while. Land use changes. Some people decide to, so let's say, for example, this is there is a protected area, and you were cultivating crops that are liked by animals. Then you decide to change what you are using there. You are planting there, so to change how we are using the land to avoid those animals conflict with humans. Live capture. Some animals are captured and taken back in the park. When they are in the field, they take them and release them back in the park. Translocation. There are around some protected areas. Some of these measures, translocation is they take animals that are problematic and they take them into another protected area. These are direct intervention, which, as I said, aim to minimize the frequency of the interaction. On the other side, the indirect interventions, they aim to to raise human tolerance for wildlife, because wildlife and humans live alongside, have even lived alongside for ages, and we still live alongside each other. So there are measures to increase the tolerance of human for wildlife, because in a way or another we will have to interact. There is no way to escape. So these measures aim to increase the tolerance of people to wildlife. Examples of those include information sharing through outreach and education programs. For example, here at the Fossey Fund, we have an education program that we educate young generation like you guys. I mean, the students. We teach the students around the park about protected areas, so that they become kind of friends with wildlife. You have crop raiders, but they are with these animals, so we are raising their tolerance. Another example of an indirect intervention is revenue sharing. Whenever there is people lose crops or an animal to, or a livestock to wildlife, there is money given to the loser by the government. So all these are aimed to to raise the tolerance of the people around the park that are suffering from crop damage or any threats from wildlife, so that they can tolerate. Compensation scheme as well. So that's giving some money to someone who has lost something. And revenue sharing, if I come back on this, is building schools and hospitals. For example, here in Rwanda, 10% of the money gained by the government from tourism, that's revenue, that 10% of the money that the government makes out of tourism goes to the community around the park, where that money goes to building schools, hospitals, and roads. So this is a way of showing the community around the park that, oh well, you are losing your crops to the animals, but some of the money that comes out of their visit can help with schools, so to raise the tolerance. These are indirect interventions. In the next slides, I'm giving you some examples of those direct interventions. I will focus on direct interventions that have been applied in around some protected areas. So for example, in Rwanda here, around the Volcanoes National Park, we have a stone wall. As you can see on this photo, there is a gorilla sitting on stones. This is the stone wall that marks the end of the park. So this and there is a trench that is behind the stone wall. So this aims to minimize big herbivores jumping outside and damaging crops and human properties. So these are effective. This stone wall is working, and the trench, they are working, they are helping, but they have limitations because they are very expensive. So the maintenance cost, to maintain them is not easy, and they cannot stop all animals living. As you can see on this photo, you can see this is a gorilla. Gorillas are very smart, and the golden monkeys as well. They can easily jump over a stone wall. So this stone wall is working, but has some limitations. So barriers in Uganda, they have tried using barbed wire fences. This was study done by Hill and Waras. So it was around Budongo Forest in Uganda, and they were targeting baboons and monkeys and chimps and bush pigs. So they set barbed wire fences around the farms to see how effective they are in minimizing those targeted animals jumping into crop fields. So these barbed wire were effective for bush pigs, but they had some limitations. Among the limitations, there were the primates can jump over because they are very smart, and chimps, for example, the baboons could jump over and have access. But they are also expensive. The barbed wires, they are not easy. Every farmer can afford to buy them. There are also potential for risk of injuries. These barbed wires have they can cause wounds to wildlife. So they are working, but they have limitations. Another example of a barrier that was tried in Uganda were the tropha hedges. These plants you can see on this photo. So these were potential. Their potential of this zatropha is that they have a kind of strange smell that deter animals. So they were tried, and the findings were that primates were never seen. The baboons and chimps and they never seen crossing this zatropha hedge, meaning that the smell of zatropha is a good repellent that can help to minimize the conflict between farmers and wildlife. So another direct intervention is the repellents. Guarding, for example, you have someone this is a photo of a hut, small house that is built around crops, and then there is someone who's guarding. So they are effective because someone is actively chasing away any animals that tries to jump into the field. And the effectiveness of this can increase by combining guarding with guarding dogs. We have we have a human being, but also he has a dog with him that can help. The combination of both of them can effectively reduce the crop raiding incidents. But they have these disadvantages as well. There are health risks from guarding in the night or during rain, so there is a risk. Some cases there are lost opportunities, such as when guarding is done by children. So in some cases, you will see guarding people are children, not other people. So they are losing their opportunities to grow into, instead of going to school, they are guarding crops, so which is not good. In some cases, also those dogs that are helping people in guarding fields, they can sometimes they are not controllable and can cause problems. So these measures are effective, but can have also some limitation and challenges. Another example of repellent that was tried around Udongo forest in Uganda was chili pest. So they basically, as you can see on this photo on the left, they applied chili on the ropes so that trying to stop animals from crossing, because the chili has that bitiness of it. So the finding, they found that this chili on the rope was effective in reducing the frequency. So the farmlands that had these ropes around them had few cases of crop foraging events, whereas those that do not have it had higher frequency of crop foraging events. So the chili pests also are used in some areas to minimize crop raiding events. The warning system that was also tried in that study of Wallace and Hill, they used ropes, and on the ropes they are putting some bells. Whenever an animal approaches tries to cross, the bell rings, and it has a warning system, and this improved the guarding efficacy, because someone guarding cannot be everywhere. So whenever there is a bell ring, or where the guard person knows, oh, there is a problem, and he goes to check what's going on there, and this has improved guarding efficacy. And the animal has learned that, okay, whenever a bell rings, there is someone coming, and it said the bears themselves could also deter animals from approaching the farmland. Again, there were some limitations, because sometimes the animals were can habituate to the warning system. Oh, it's a bear, that's a bear, and just they cross. So there are some limitations. And another limitation is that there is a need for a fast response. Whenever there has to be always someone to intervene, particularly when there is habituation. So whenever a bell rings, there has to be someone who is there to respond and chase the animal away. So other techniques that are being used are virtual fences. As the word say, virtual. So these techniques have to create barriers, but that are not physical, and they aim to change instead the behavior of the animals instead of using a physical barrier. So these techniques the virtual fences aims to alter animal behavior, and these virtual fences can be more effective where physical barriers are not working well and have negative impact on wildlife. For example, when you have those barbers wild, for example, I have just mentioned it, they can injure animals. So instead of using barber wire that can, injure animals, you can use virtual boundaries which are not, do not have I would say huge negative impact on wildlife. And the good thing with those virtual boundaries is that they are species specific, because you have to target one species and train it to respect the boundaries. So examples of the virtual fences that are being used, some examples are sensory deterrents. I will come back on this in a short while. Animal mounted training corrals, real-time virtual fencing, and biological virtual fencing. Starting with the sensor deterrent, these are, as the word says, sensory. So they are techniques that are used that use cues perceived by animals' sense organ to deter wild animals. So examples include an prison test. So, for example, in Australia, someone in a study used test aversion technique to reduce predation of native marsupial by introduced red foxes. So there were red foxes that were introduced in a forest in Australia, and they were killing native marsupials, and they used test aversion technique to discourage the foxes from killing native marsupials. An unusual smell. This was used in some protected areas where they used smoke. They burn or they put fire on dried chili, and the smoke from it is perceived. The smell deters wild animals from approaching fields. Frightening noises. In some places they play noises of, for example, a lion. When you play a noise of a voice of a lion, and then the crow played, if it is a duca, will not approach a place where the noise of the lion was played. So these fighting noise are also used to repel crop foragers or other dangerous wild animals. Scaring moving objects were also used, like flags. We see on this next photo on the left side. This is a scarecrow. So this is something that is tried here in Rwanda. Farmers try to make something that can scare away crop raiders. So they can see something, oh, maybe that's a human being standing there, and they run away. You can see also on the right side, sorry, where these red flags are used to dissuade wolves. Whenever a wolf see this red flag, oh, this is dangerous, I cannot cross. So these are visual cues that animals can see and then stop their bad behavior. Another virtual boundary is animal-mounted training corrals, as you can see on this photo on the left. So the animals they put collars on animals, and then whenever the animals are trained to respect boundaries, whenever an animal goes beyond, the way this works is there is an area where the animal is allowed to move, but whenever it goes beyond some limits, the animal receives a shock, and the more the animal receives a shock by going beyond the limits, it learns not to go beyond the set limits. So this, by receiving a shock, the animal, whenever it goes, I go beyond this, I have a shock. Then the animal learns to stay in the same place. It's not widely used in the wild, but it's used in farming. People with cows, they use this technique to teach them not to go beyond some limits. But it has the potential of being used in wildlife. Another virtual boundary is real-time virtual fencing. As you can see, this lies on technology. You can see there is a computer on the right side. These are bosses in the office. They have their computer. And on the right side, left side, so you can see an elephant. The elephant is tagged with a chip, and then the chip sends the signal to the antenna. And the bosses in the office, the park management people, can see the movement of the animals, and they know the limits of their protected area. Whenever an animal approaches the border of the protected area or goes close to farmlands, or then the bosses make the decision, then can you go and bring back that elephant that's going beyond the limits of the park. So this is an example of a real-time virtual fencing. So there is no limit, there is no physical barrier there, but virtually there is something that is helping the park management to stop those animals from going beyond the protected areas and the damage crop or kill people. Other example of virtual boundaries are biological virtual fencing. This, as the term says, biological. So they use living things. So for example, some use animals to create a barrier around protected areas, and the other use a buffer zone of unpalatable plant species. So for example, in Zimbabwe, they have used a chili pepper plantation around the protected area. So that chili pepper plantation, those are plants around as a buffer zone. Then the animals, because they do not eat the chili pepper, they cannot go beyond this. So this is an example of biological virtual fencing. Beehives were also used to stop elephants in Kenya. So they have a protected area, and around the park you have beehives. Elephants are very afraid of bees. Whenever you have those beehive around the protected areas, the elephant will not cross. So it's kind of protecting animals using other animals. Guarding dogs were also used to deter baboons in Uganda. You have dogs around the park, and animals know, oh, whenever I go out, I will find a dog there. So this is a biological fence. So the next part of my talk is me sharing with you, as I said, my project that investigates human-wildlife conflict in golden monkeys of the Volcanoes National Park around the park. So this photo on the screen is a monkey. It's a golden monkey. They love potatoes so much. You can see this is a male monkey, so he's enjoying a couple of potatoes that he has dug from potato field. So crop raiding is one of the main causes of human-wildlife conflict, challenging conservationists worldwide. So around many protected areas, there are crop foraging issues with wildlife dumping out and damaging crops. And the primates are frequent raiders in many protected areas. As you can see on this photo, for example, these are gorillas here around the Volcanoes National Park. They sometimes go outside and destroy eucalyptus trees and they eat tree tomatoes. So it's a problem around many protected areas. And this conflict, this crop foraging behavior negatively affects not only farmers' livelihood when they lose their crops, but also the conservation of involved primate species, particularly when farmers get angry and kill some of those wildlife. So why golden monkeys? I focused my project on golden monkeys because they are endangered and they only exist in two small populations. One population is in the Virunga Massif, you can see on this map, and another small park called Kishkwati National Park. My study focused on the golden monkeys of the Volcanoes National Park, which is the one side of the Virunga Massif. So as you can see on this photo, the Volcanoes National Park is directly adjacent to farmlands. And you see on the left side is the park, on the right side are farmlands. And on the farmlands, you can see these are potato fields basically. And farmers have potatoes directly close to the border of the park. And there is high population density, so many people around that protected area, which is an issue for conservation. So in the Volcano National Park, golden monkeys, which are a problem, live in bamboo zone, which is the nearest to the park boundary. As you can see on this photo, you see there is the stone wall, and you can see bamboo on the right side, and farmlands directly other side. And because the monkey live in the bamboo zone, they can easily jump and go in the potato fields. The population of the golden monkeys is estimated to now to 4,600 individuals. So the number of them is pretty high. However, there was no records of crop raiding until at least mid-90s. So in the 90s, there were no records of crop raiding by golden monkeys. But recent studies in 2010, 15, so that now the golden monkeys, because the number has somehow increased, recent studies list golden monkeys as the second raiders. So probably because the number of them has increased, and as I said, there is high population density around the park. The population rely on relies on subsistence agriculture, they need more land. So they are cultivating more potatoes close to the park because they need to survive. So recent studies have shown that the monkeys are an issue. And more importantly, the golden monkey challenged the existing mitigation measures so they can easily jump over this stone wall because they are smart. So what did I do in my project? I used an integrated approach using a combination of approaches. First one was a structured survey to evaluate the impact of the conflict for monkeys and farmers. So I interviewed 40 farmers to get their feeling about golden monkeys conflict. I also organized a workshop to discuss a workshop that involved stakeholders in conservation. You can see on the top right photo. This was the workshop. I had gathered all stakeholders of the Volcanoes National Park, park managers, and NGOs that are involved in conservation of the Volcanoes National Park to discuss the effectiveness of possible mitigation measures and also propose new ones. I also did some behavior observation to document behaviors of monkeys, how were monkeys behaving inside versus outside. Probably this could give us information on how they perceive being outside. Lastly, I tried a test subversion experiment. As you can see on the right bottom photo, this is me. I had potatoes, and on the potatoes, I smeared some chili oil. So trying to test the feasibility of test aversion to discourage monkeys from foraging on potatoes. So test aversion is a technique when you have an aversion to something, you don't take it again. So when you taste something bad and you feel it doesn't taste good, you avoid it the next time. So that's the basic principle of test aversion experiments. I was trying to see if this can work in golden monkeys. If they eat on a potato that has chili on it, maybe they will not eat potatoes again. So what were the findings? My findings were that 95% of the participants had experienced the potato loss to golden monkeys. So that is, they had monkeys that visit their fields. This is a high percentage. Another observation was that 36% had used the potential harmful methods to stop foraging. By harmful method, I mean chasing. You can see on the right photo, the female, there is a lady running after a monkey. So running after them, throwing stones to the monkeys. So these are some of the harmful methods that were used by farmers to try to stop foraging monkeys. Another finding was that a few cases of adverse impact on monkeys were described. So for example, a few cases of killed monkeys were reported and injured. So these were the findings of the survey. During the workshop discussion, we were discussing about mitigation measures, and crop guarding was perceived as the most effective mitigation measures by workshop participants. But the workshop participants, as I said, the stakeholders in conservation around the park, agreed on that the existing guarding measures need to be improved. So guarding is working, but it needs to be improved by the government supporting the guarding, and needs to be properly organized in a cooperative so that we can increase its efficiency. Because farmers believe that guarding is effective, conservationists believe it's effective, so it needs to be improved. That was the outcome of the workshop. So behavior observation revealed two important observations. First, that monkeys were very social, while inside the park. They could see high frequency of playing, grooming, social behaviors inside the park, suggesting that they were feeling relaxed. On the other hand, when they were outside, the vigilance behaviors were more prominent. So they were more vigilant. As you can see on this photo, bottom photo, you can see a monkey standing on his 2 legs. So this is on farmland. They have to be vigilant, which suggests a high level of perceived risk by monkeys when outside of the park. So the taste salvation experiment we have tried, we put some potatoes that were smeared with chili oil on the ground outside the potatoes, outside the park, sorry, on the ground in harvest fields. Our finding, to our surprise, the monkeys, despite them loving potatoes, they did not eat potatoes smeared with chili oil. They fed on unattained leftover potatoes instead, which suggests that the smell of chili could potentially deter them from eating crops. Here is a short video that summarizes what I just come to say about the taste salvation experiment. Just for your information, golden monkeys love potatoes so much, so much. You can see this one digging a potato under the ground. So they love potatoes so much, and surprisingly, during our experiment, you see, this is the first monkey that visits the experimental area. So on the first day, a male monkey came outside the park and picked one potato that was smeared with chili oil. He gave it a shallow bite and a sniff, and then discarded the potato. He moved on the second potato. He gave just a smell and discard the potato, ignoring the third potato that was on the spot. So the same male monkey continued feeding in the experimental area, around the experimental area, ignoring potatoes smeared with chili oil, but only feeding on leftover potatoes that were not smeared with chili oil, and feeding on grasses around the experimental area. So shortly we see on the second day of the experiment, the same monkey came outside the park and visited the experimental area. And what happened is that the male monkey now was feeding the experimental area, but did not touch at all the potatoes that were smeared with chili oil. There were potatoes on the ground in the experimental area, but he just moved around, not picking any of those, instead picking those that were not attained, so with chili oil, only leftover potatoes and grass in the experimental area. So this is what basically happened during the experiment that we have tried. So in conclusion, the survey outcome and the behavior changes shown by the monkeys in farmland indicate that crop foraging by monkeys around the Volcanoes National Park can negatively affect both monkey conservation and the farmers' livelihood. So the monkeys are losing, so the farmers are losing their potatoes, but also the farmers potentially are also harming the monkeys, which is an issue for the monkey conservation. Overall, our combination of approach showed that existing mitigation measures, there are measures that are working, but they need to be improved, while alternative measures should be further explored, like the taste salvation I have tried. Even though it did not work as predicted, because the monkey avoided eating potatoes that were smeared with chili oil, but we can explore the feasibility of it in another setting. For example, in farmers' storage, the monkeys can jump, they can go into farmers' houses. So if you have your potatoes at home and you put chamu chili on top of them, maybe the monkeys will not, when they enter the house and they smell the chili, they will not eat the potatoes stored in homes. So these measures needed, because we need a positive coexistence between golden monkeys and farmers through reduced crop spreading. Because if we improve those mitigation, if we try mitigation measures that can help, So this coexistence between monkeys and farmers. Farmers will learn to tolerate the monkeys and thus improve their conservation. So that was just a summary of my publication. That my work on the monkeys, it was published. You can go and read it in more details. As Kristen has said, we will be shared with the link to my publication. You can go and read it in details. So I thank all my supporters. I had support from Fossey Fund and Chester and Prime Minister of Britain and government of Rwanda. And thank you all for your kind attention. If you have some questions, you are most welcome.
Thank you very much, Eric. That was an absolutely super presentation, and I think it gives a really great and comprehensive foundation to us all about human-wildlife conflict. Yeah, and your case study of the golden monkeys was wonderful, very, yeah, illustrative and powerful. I'd like to, I've got a couple of questions myself, but then I would like to just open the floor up to all the students and our additional audience for their questions. And yeah, audience, you're welcome to raise your hands, your virtual hands under reactions at the bottom. There's a toolbar called reactions and you can raise your hands. Otherwise, you're welcome to write your question in the chat. So Eric, my first questions, one of them is a really burning question, and that's a pun. Do you eat chili now after all your research? Because you've been handling a lot of chili.
I don't like chili naturally, so I don't eat chili.
Okay.
Someone else at my place do.
Okay. And then on a more serious note, right in the very beginning, I think it was your first slide, when you were introducing yourself, there was, you had a mask on and you had the gorillas in the background. And I just want to know, why were you wearing a mask?
Yeah, good question. That came when COVID hit. So when COVID hit, we had to start wearing the mask whenever we are with gorillas, because human and gorillas, we are closely related genetically. We can pass things to each other. They can give us something disease-wise. We can give them something, particularly respiratory diseases. And the gorillas are very sensitive to respiratory diseases. So that's why we have to wear those face masks whenever we are following gorillas. Same, this applies to researchers, me included, and to tourists. Whenever you are with the gorillas, you have to wear a mask. Is compulsory to minimize giving them something germ-wise, something like that.
Thanks, Eric. Okay, I see Dr. O has a student. Would you please introduce yourself?
My name is Bongani Mayaba from TUT, South Africa. I have a question. My question is, so what are the probability of an alpha monkey actively pursuing a prey, capture it, hunt it, and then eat it? Like, what are the probability of that happening? Because I've seen a video of a monkey doing that. And then, is that a normal behavior for monkeys to actively hunt? Or maybe it's not normal? And also on that of, a question on that of compensation scheme, is it working so far, or is it a successful method on solving human-wildlife conflict? Thank you, sir.
Yeah, thank you for your questions. I think the first one is, where, if I got it right, you are asking an alpha monkey killing another, hunting something. To my knowledge, the golden monkeys we are following here do not hunt. So the monkeys we follow here do not hunt, if I got your question right. So the monkeys you have here, they feed on grass, basically. They don't hunt, and they are not hunted because there are no predators for them, except some dogs that can come from the community and jump in the forest and run after the monkeys. But the monkeys here are not preyed on, and they don't prey on something else. So I'm not sure if I captured your question very well. So the second one is whether the compensation scheme is working or not. I would say it's tricky for the monkeys, and that was one of the recommendations during the workshop we have organized it. So the compensation here focuses on big mega herbivores, like elephants, buffaloes, and gorillas. When gorilla damage crops, there is compensation. But for the monkeys, because they are small in size, it is very hard for the government to assign monetary value to the damage done by the monkeys. So it's tricky, but we had advocated for that because the monkeys are increasing in number, the frequency of crop breeding is increasing, so there has to be done, something has to be done. So we had to advocate for that so that the government can consider also compensating for those small herbivores like the monkeys. But so far, for the mega herbivores, it works. The government does its best to, whenever there is a damage, the government is there and does give the money to the farmers, and I believe the farmers are happy with that.
Thank you, Eric. I see another student. You're welcome to ask your question and just give an introduction to yourself first, please.
Morning, sir. My name's Luke. I wanted to ask a question in terms of the scarecrows used in able to deter animals, particularly primates. Would these animals not become like almost habituated to the scarecrows, and that effect becomes inefficient over time?
Yeah, good question, Luke. And yeah, that's one of the challenges I have mentioned of over habituation. So the scarecrows can work in the first instances. The animals can feel, oh, this is a human being standing there, and the animals do not approach the field farms. But there is a risk of habituation. That's why in human-wildlife conflict, not one measure is used. It's a combination of many. You will not say, oh, well, I have a scarecrow in my field and it's enough. So you have to, there is a combination of many techniques that has to be used. Guarding, scarecrow, compensation, to ease the coexistence between the wildlife and farmers. So not one measure can stand alone and do the job. So there has to be a combination of many to do the job.
Thanks, Eric. Do we have any? Oh, here we go. We've got another question. Right. So we have a question by Michael. Michael Make or Make Montana. Michael asks, please kindly explain the slide on the real-time virtual fences. So if you can go back to that slide.
Yes, I can go back to the slide. I think this. Can you still see my slides or? Not
yet, Eric.
I have to share again. I'm coming in a while. The real-time virtual fencing is a technique used by park managers, and as I say, it's a kind of virtual boundary. There is no boundary around the park, or there is, but it's not efficient for the target animal. And how it works is the bosses. It's based on georeferencing and tagging the animal. So the bosses of a protected area have a screen, and the animals like an elephant this is an example of an elephant on this photo. They are tagged. They have chips which are georeferenced, sending a signal to the bosses where they are. So from your office, you can see where the movement of the animals, and you have the boundaries of the park. Let's say this crossed line is a park, and you can see this elephant goes close to the boundary. Whenever the elephant is inside the crossed line, it's okay. The elephant is still in the park. But whenever the elephant approaches the border of the crossed line, so the management in their office, they can see on screen, because the animal is tagged, they can see, oh, the elephant is close to to the southwest side of the park, and that's where there is a maize field of crop somewhere. So the boss went, let's go and bring back that elephant. So that's how the real-time fencing work. So trying to bring back the animal whenever it approaches the boundaries, and it's based on technology, microchips, and sending signals to the boss, and the bosses can make. It's called real time because the bosses can make decisions immediately whenever they see something happening. Hopefully, I covered everything. You are muted, Kristen. You are muted, Kristen.
Oh, thank you, Eric. Yeah, no, I was just saying, I think it was quite a comprehensive question, so and answer. So yeah, I think it's all good. I just want to, yeah, I'm going to, there is a question in the chat, but I'll come back to that. So I'm going to first open it up to Dr. O's students. You're welcome to ask your question.
Good day, I'm Robin. I'm one of the TET students. I just want to ask about the potatoes. Do you use already picked potatoes and then paint them with chili, or do you paint the grounded potatoes with chili? And then also, how many do you paint in comparison with the whole field? Because I was thinking, if you're going to paint all or a lot of potatoes with chili, how are you going to then later use that if they're covered with chili? Thank you.
Yeah, good question, Robin. Yeah, the question is on test aversion experiment that I have tried. What I described in my study was an experimental study. So I did that just once. I set it one experimental area a day, just let's say 10 meter. Maybe I can go to the slide that describes it very well. So the thing, Robin, the thing was, this was done during the experiment when I was doing my study. It's not something we do on a regular basis. This was during my study, and the potatoes that we smeared with chili was those that were dug already, harvested potatoes. Not every potato in the field, just in the experimental area, which was 3 meters away from the park, as you can see, and you had like 10-meter long kind of transect. So we did not smear chili on all the potatoes, just a few potatoes, and only a few potatoes in the experimental area, which were like 10-meter long and let's say 6-meter wide. So only potatoes for the experiment were smeared with chili oil. Not every single potato, just few for the experiment.
Super, thanks, Eric. If I can just ask that Dr. O's students, when they ask their question, can they just stay while Eric answers, just so that we can make sure that he has answered your question to your satisfaction. Okay, so I'm just going to read a question in the chat first. This one is by Sosvelo Twala. And he asks a question that I was actually going to ask as well. He says, have there been cases where animals with electric colors die due to electrocution, or the voltage levels that have been, or are the voltage levels put to a safe enough level? And also, does the electric voltage levels differ with animal size? And I just want to add another bit onto that, Eric, is do those colors result in a higher predation rate of those colored animals? So those are the questions we can remind you if you forget anything.
Yeah, I would tell you if I forget anything. So those are based on my readings. I haven't ever haven't personally collared an animal. So just me reading and cases or techniques that are being used elsewhere to stop animals from raiding. But the collars, as I have said, they are used in the farming settings. Some people have, let's say, cattle, and they want their cattle to go beyond some limits. So there is a possibility of using the techniques in wildlife, but to my knowledge, I don't know a case where it has been used in wildlife. It was just an example of a technique that can be applied to minimize a conflict. But people having cattle, for example, use them to, to train their animals, their livestock, to not go beyond the limits. And the question about the size of the animal, I don't know how the techniques is done specifically, but I bet the people responsible of controlling the animals have to make sure they are doing it right. The size of the animal, how the intensity of the shock, to make sure it doesn't kill the animals. They have to find the right balance between, training the animals, but not also harming it. It has to be ethically approved, I think.
Thanks, Eric. And on the predation thing, are the colors heavy or something that results in more predation? Do you know?
Say again the question?
Do the colors result in a higher level of predation, that the animals are heavier because of the color, or are those colors very, very light?
I have no idea to be honest.
Okay, cool. Okay, so we have another question with Dr. O's class. You're welcome to go ahead and ask your question.
Hello, my name is Kanyisile, and on behalf of the TET students of Nature Conservation, I would like to say thank you so much for your enlightening presentation on human-wildlife conflict. Your insights shed light on an issue that affects both humans and animals deeply. And we are so grateful for your time and dedication and sharing your knowledge with us today, Mr. Eric. We are so grateful for you. And we're going to use this information on our upcoming assignments on human-wildlife conflict. And I'm sure all of us are going to think critically when you answer questions concerning that assignment. So thank you so much.
Thank you, Councillor, for your appreciation. And I have one recommendation for you. I've been a student as well, and I'm still studying. Recommendation is you go and read my publication. There is more details about everything I have just said. So you can get a lot from there. So go and read, and I know you'll do excellent in the exam of human life if you read the paper.
Okay, thank you so much.
Yeah.
Super, Eric. That's lovely. Have we got any more questions, Cheryl, or is that you guys happy?
I've just got a comment. I've divided my whole class, 127 students, into various topics, and there is one group that's doing it on monkeys, a very broad topic on monkeys, and they will definitely be reading your paper pertaining to this, because what I saw today is a lot of things that are coming up, and they're kind of repetitive, where you got beehives, the chili coming up, the barriers. So these things are virtually being used for a lot of species. I'd just like to know, in your video, there was the golden monkey. He was walking around and he picked up, yes, a red potato, which was obviously covered in chili. And he took one bite and he moved on to another potato, which didn't have chili. So is this showing that monkeys are very intelligent, and now they can distinguish between a red potato and a brown potato? And then he may just not touch your red potatoes at all. So he may just go on to all the brown potatoes. That's just a little comment.
Yeah, I was not in the monkey's head, but I think they are smart. They're smart from our observation, from my observation while recording the experiment. I think they are smart enough to know to tell the potatoes apart. This potato is, it has chili on it. This is not tend with chili. So they are, I think they are intelligent to tell the potatoes apart, to screen a good one and a bad one, and go for a good one.
Is that good, Dr. O? Happy?
Yeah, I would also just like to say thank you very much, Eric. I loved your talk. I can't wait for it to be a YouTube, and so my students can actually revisit it, because it's not just going to be part of their assignment, it's also going to be part of their next upcoming test and the exam. So human-wildlife conflict is a big part of their studies this year. And let's hope we can actually make a difference and learn from you and the other presenters that have actually presented to my students, because they're going to be dealing with this one day. They're going to be managers of green zones and protected areas, and they will have to know how to deal with elephants and how to deal with monkeys and crocodiles and whatever. And these are just tips and tricks that you guys are so gladly shared with us. And I would like to say thank you.
Thank you very much for your appreciation, and yeah, I'm very happy you love it.
Thanks, Dr. O. Eric, we've still got you for just a couple of minutes. I just wanted to bring up a couple of things that were commented in the chat. So they're not questions, but just little comments. So the last one actually is by Karina Creighton, and she just says, thank you so much for this interesting presentation, Eric. Good luck with your research. So that's from Karina. Thank you, Karina. And then there is another two more comments, one by Peter Apps. And he says, food aversion conditioning needs a treatment that animals mildly sick after they eat the treated food, but that they cannot they cannot detect. If they can detect the treatments, then they avoid only the treated food, as you found for chili oil. If they cannot detect the treatment, then they avoid both treated and untreated food. It is also far more effective if the animal has not already got into the habit of eating that food. If a young monkey gets sick the first time it eats a potato, it will not eat anymore. Do you want to comment on Peter's comment there?
Yeah, I think it's a good comment, and it matches up with our findings, as he says or she says. We were surprised. I mean, our test observation experiment did not work as we had hoped. Maybe because they are used to eating potatoes already, or the technique used was not that efficient enough for them to to eat the potatoes. And it's a good comment, and yeah, that is very useful. And I would say whoever else, that's why we have shared our findings in our publication. So we did something, did not work as we intended, maybe was not well planned, but we say it's worth sharing this for others who are in the same field and want to try the same thing. They know this is what happened on our side, and I think it will be helpful for other people interested in testing test aversion.
So there we go, Peter. The challenge is all yours to carry on the studies. Okay, and then there's a comment from Ernest Oriba, who says, thank you, Eric, for the presentation. I think it would be great if the study was done for a longer period of time, 2 to 4 years, before concluding whether the experiment really yielded positive results.
Can you say the comment again? I didn't get it right.
Okay, he said, thank you, Eric, for the presentation. I think it would be great if the study was done for a longer period of time, 2 to 4 years, before concluding whether the experiment really yielded positive results.
Yeah. I think maybe I didn't put it right in my saying, but if you read my publication, you will find that we were very cautious into giving conclusions. We said did not work and tried to find explanations around it. So if you go deep in the publication and go on the section of test observation, everything is well said there. I think we were cautious into jumping into making conclusions because it's not conclusive.
Super, Eric. Yeah, I think that you've really added a very positive contribution by publishing that paper. And it's always there's such a value in publishing one's research to share with others and for them to take it forward. So, Eric, with that, I see there's no more questions, and I think that we can just say a final thank you to you. It's been a very excellent presentation, and yeah, really appreciate you sharing this work with us.